Good morning, students. I have posted a new assignment for you on Canvas today. It is titled The Law of Conservation of Momentum, the Two Spheres, and the Bullet. So there are two problems on the assignment. I would like to complete the first problem with you. So what I'm going to do is read the problem. I'm going to underline important information. I'm going to generate a column of knowns and unknowns, and I'm also going to draw two pictures, so before the collision and after the collision. Okay, so here we go. A 0.5 kilogram sphere traveling at 3 meters per second collides head-on with a 0.75 kilogram sphere moving in the opposite direction at 5 meters per second. The 0.5 kilogram sphere bounces backward at 6.6 meters per second after the collision. What we're going to do is calculate the velocity of the 0.75 kilogram sphere after the collision. So, mass A, or sphere A, we can go ahead and say the 0.5 kilogram sphere is mass A. Mass B is going to be our 0.75 kilogram sphere. So what let's do before we fill out the rest of our information in our column of knowns and unknowns is let's go ahead and draw a before and after picture. So we have sphere A right here moving in a positive x direction. So remember, velocity is a vector, so it does show direction and magnitude, and we have a positive value associated with that. So our initial velocity for sphere A is 3 meters per second. Okay, sphere B, which is 0.75 kilograms, is moving in the opposite direction at 5 meters per second. So it's moving this direction, velocity, 5 meters per second. Now let's go ahead and put our velocity information into our knowns and unknowns. So initial velocity of object A, we're moving in a positive x direction. This is 3 meters per second. Initial velocity of object B, now we're moving in a negative x direction, so we're going to associate a negative value with our velocity. So negative 5 meters per second. Now, after the collision, it tells us that sphere A bounces backward at 6.6 meters per second. So, drawing object A, now it's going to bounce back. Final velocity, 6.6 meters per second, okay? Since it's moving in a negative x direction, let's go ahead and associate a negative sign with that. So negative 6.6 meters per second. And sphere B, well, at this point, we don't know what it does. So this is our unknown, the final velocity for sphere B. Now, in order for us to solve this problem, what we're going to do is use the law of conservation of momentum. And this tells us that in a closed, isolated system, the momentum is conserved. So applying that here, that means that the momentum for the system after the collision is going to equal the amount of momentum the system has before the collision. Now, the law of conservation of momentum tells us that in a closed and isolated system, the momentum is conserved. So a closed system means that no mass is lost or gained. Okay, so the mass is going to be constant in our problem. Also, the isolated system means that there's not going to be any external forces acting on our system. Okay, so let's start with the equation here, law of conservation of momentum. We have the sum of the initial momentum of the system is going to equal the sum of the final momentum of our system right here. So we have the Greek letter sigma, which means the sum of. So our initial momentum for object A and B is going to be initial momentum for object A plus the initial momentum for object B. So the sum of this must equal the final momentum of the system. So the final momentum of object A plus the final momentum of object B. Now we know that momentum is the product of an object's mass and velocity. So momentum for object A is going to be mass of A multiplied by the initial velocity of object A plus the mass of B multiplied by the initial velocity of object B equals the mass of object A multiplied by the final velocity of object A plus the mass of B times the final velocity of object B. Now, we actually know all of this information. The problem gives it to us, except the final velocity for sphere B. So this guy right here, this is going to be our unknown. So to isolate this, we're going to have two algebra steps here. The first thing we want to do is subtract the product of mass of object A and the final velocity of object A. So this right here, we're going to subtract this from both sides of the equal sign. So on the right hand side of the equal sign, this is just going to leave mass of object B multiplied by the final velocity of object B. So we are going to divide by mass B to isolate the final velocity of object B. So the equation that we're going to have is final velocity for object B is going to be mass A multiplied by the initial velocity of object A plus mass B times the initial velocity of object B minus, because remember we had to subtract this from both sides of the equal sign, so minus mass A times the final velocity of A, all divided by mass of object B. Okay, so on the right hand side of the equal sign, we actually have all of the values. So let's go ahead and fill in our values, and we can solve for the final velocity of sphere B. So mass of object A is 0.5 kilograms. We're going to multiply this by the initial velocity, and it's 3 meters per second. Remember, this is a vector. It's traveling in a positive x direction. So 3 meters per second plus mass B, 0.75 kilograms. We're going to multiply this by its initial velocity, which is a negative 5 meters per second. So it's going in a negative x direction. Minus, remember that we had to subtract the product of mass of sphere A and the final velocity for sphere A. So mass A is 0.5 kilograms, and the final velocity is a negative 6.6 meters per second. We're going in a negative x direction. So negative 6.6 meters per second. And we're dividing this by mass of sphere B, so 0.75 kilograms. Okay. All right, so what let's do now, let's go ahead and take out your calculator. Let's just resolve the numerator for our first step. So final velocity for sphere B. So right here, this is going to be 1.5. Here, that's 1.5 kilogram meters per second plus, so I've got 0.75 times negative 5. This is going to give me negative 3.75. And our units are kilogram meters per second minus, we have 0.5 times negative 6.6. This is going to give us negative 3.3 kilogram meters per second, and we are dividing by the mass of sphere B, 0.75 kilograms. So final velocity for sphere B in the numerator. I've got 1.05 kilogram meters per second, and we're dividing by 0.75 kilograms. So let's talk about the numerical value first, then we'll talk about the unit value. So 1.05 divided by 0.75 is 1.4. Okay, now looking at the units here, in my numerator I have kilogram meters per second, and we're dividing by kilograms, which algebraically we can actually write this like kilograms over 1. And we need to refer to the algebra rule, where whenever we divide fractions, it's like multiplying by the inverse of the denominator. So what I have here is kilogram meters per second times 1 over kilogram. And we know that kilogram is going to cancel here. That's going to leave us with units of meters per second. So what we have, the final velocity for object B, is going to be 1.4 meters per second. So on our after collision picture, we need to go ahead and complete this. Remember that velocity is a vector, so this is a positive 1.4 meters per second. That means it's going to be moving in a positive x direction. So sphere B, final velocity 1.4 meters per second. All right, so if you need any help, please send me an email. When you get done with this assignment, take a picture of it or scan it and attach it to an email and send it to me. I hope you guys have a great day.